let's learn more about loop composition. You can calculate the mean or average of a list by adding together the elements and dividing by the number of elements. Finding the average is a common operation for a list. You could write this function by creating a loop that combines the sum and count patterns. Alternatively, you could define functions to sum and count, and then use those functions in your average function. This version does not require a loop directly in the average function because the loop happens indirectly in a helper function. Earlier, we learned to break up complex functions into multiple parts using functional decomposition. With loops, we finally see why that becomes necessary. The control flow for a function with a loop is complicated. When you start nesting loops and if statements inside of functions, mistakes are likely. Functional decomposition allows us to tame that complexity by focusing on one conceptual step at a time. Let's say that we want to add up all the negative numbers in a list. You could write a for loop that combines the filter pattern and the count pattern. You might even succeed. But what if you also needed to convert all the elements from strings to integers first? What if you also need to find the average? Suddenly, combining all of these patterns becomes difficult. Instead, let's focus on defining functions to solve each part of the puzzle in turn. We define a map_strs to ints function that maps strings conversion over a list of strings. We define a remove negatives function that filters out negative integers. We define a count and sum function that consumes lists of integers to accumulate. Then, we can compose those functions as needed into an average positives function. This may seem like a lot more work. Suddenly, we have to define and test 5 functions instead of 1. But the advantage is that each function is relatively easy to define and test. If you make a mistake, you will be able to track it down very quickly.